Hello again, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist, DT, from weatherist.com, the kernel of confusion, the captain of catastrophe, the commander of chaos. It's time to talk about weather again, and we're back for the autumn season into the winter and the spring. So we'll be producing these videos once again well, usually on the weekends, but sometimes on Mondays, depending on the workload. And we'll be talking about the hurricanes this season, so lots to talk about in this first opening edition, and hopefully making some upgrades to the video as well if everything goes according to plan. So we'll start out by taking a look at some interesting concepts that we use here at weatherist.com. And I wanted to present first two different methods for looking at and forecasting hurricanes potentially, or winter storms, or any sort of significant weather event. There's two different methods here, and one is the hype or clickbait method, and the other one is the skeptic method, which is the weather risk way of doing things. So when you're doing the hype method here, first what you want to do is you want to start off with the most exciting possible ominous looking model solution out there. And then you show it often. Let's call this solution XYZ. Now, the next step, of course, is to ignore other solutions or possible outcomes. And then step 4 is more and more data turns against solution XYZ, you still trying and spinning to come up with a way that XYZ is still viable. Then you insert some sort of irrational, goofy platitude like my experience or I'm looking at the overall pattern. Then finally, in step 6, you express hope that the last minute changes may still support your XYZ solution, even if no other data supports it. And then finally, you spin your busted forecast into, well, I almost got the pattern right, or what have you. Now, in the skeptic method, the weather risk way, again, you will start out by finding the most exciting or ominous possible model, but then you remind folks that the solution XYZ is just one possible outcome, which may be rather extreme. You present other solutions and possible outcomes. Then as more data comes out, these obstacles or barriers to solution XYZ, you point them out and say, well, XYZ can only happen if this happens, if this happens. And then as more and more data comes in, you see if these barriers begin to fall, these obstacles begin to break down. And as a result, if they do, you can start saying, well, maybe XYZ is possible. And that gives you increasing confidence in the forecast instead of trying to backtrack or backpedal or spin the forecast into something else. And if the trend continues in step 6, you can sound the alarm. And then you can consider the possibility of an asymmetrical outcome or perhaps even a black swan event. And finally, in step 7, you never strut, you do a review, and you be honest. After all, it's science and not ego. All right. We'll be talking in this topic here. We'll be talking about, like we said, the hype method versus the skeptic method, we just went over. And then we'll be talking about system 99L and 90L, which is now tropical depression number 7 and soon to be tropical storm Gaston. And then the overall pattern for next week of these systems to see if they're a threat to the United States. Now, this is the satellite picture from Sunday. And what I wanted to point out here is how impressive this system looked coming off the coast of Africa. I mean, you can already see some feeder bands going in this way. You can see the cyclonic curvature going off Africa. Now, this one here, okay, that's this is I guess this is 90L. This and over here is 90, and this is Fiona over here. So now Fiona looked kind of dead, but it still had some convection to it. So each one of these systems has its own reasons to be optimistic or excited about. And you can even see some cyclonic spin here in 99L, even though it's not very organized. So that's what's significant about this, right? Now this is the 5 o'clock advisory from the Hurricane Center. You can see Fiona, you can see the system there, 99L, then tropical depression number 7. Bang, bang, boom. And we've all seen that graphic before. Now this is the afternoon satellite picture from the Monday afternoon. And again, you can see, look how impressive this tropical depression number 7 is looking already. Distinct bands feeding in. Look at this. You can see the cyclonic curvature already into this thing. Very impressive looking feature. Now this over here is one over here. This is 99. This is 99. Yeah, 99L, and over here this is Fiona over here. So, but you know, even the system approaching that tropical wave at 99L, that's still looking pretty decent in its own right. Okay, next slide. Now let's talk about Fiona a little bit. Now earlier yesterday and last night, it looked like all the models were taking the system, as you can see, out to sea. You can notice all they parallel along the East Coast, maybe a threat to Bermuda, maybe even eastern Bermuda. But what's happened is there's been a bit of a change. This is the 18Z Monday models. And what's happening here is that the models are seeing this enormous dome which develops here, high pressure, over the southeastern states. So as a result, Fiona goes this, and then it begins to turn back to the west towards Florida a little bit. And this is kind of a change. And I'm beginning to get a little worried that Fiona may yet make landfall. I don't know if it'll even be a system, but I'm not sure it's going out to sea at this point. This is a pretty big change in most of the hurricane models. So as we consider that, we can consider the sea surface temperatures. Now, notice that most of the really warm water is off the east coast and mostly in a little bit in the Gulf of Mexico, Caribbean. Actually, the tropical Atlantic, especially north of the Cape Verdes, is actually kind of chilly for this time of year. And this is important because the research has recently been done which shows that hurricanes in the tropical Atlantic essentially come in four different types or clusters, and they're all dependent upon the sea surface temperature and patterns of the tropical Atlantic Ocean. So for example, in pattern number 1, notice we have a lot of cool water up in here and then mild waters in the tropical Atlantic. In pattern number 2, it's cold here and then off the coast of Africa, but warm in the Caribbean. Pattern number 3, it's warm in the entire tropical Atlantic, but off the southeast coast and the Gulf of Mexico, it's not that warm. And then area 4, everybody's warm, as you can see. So as we look at the current matches to the previous slide here, we can see we're not really seeing a lot. If anything, it kind of looks a little bit like a slide number, I guess, no, slide number 2 with the cool water off of Northwest Africa. But we don't really have a good match right now. And the reason why this is important, because look at all these different clusters here. Most of the hurricanes, which are cluster 4, which is that warm water, stay in the Caribbean and then come up to the Gulf of Mexico. Cluster 3 are mostly East Coast hurricanes. Cluster 2, that's Gulf of Mexico. And then Cluster 1 are mostly hurricanes which go out to sea. So this is really useful information when you're trying to figure out how the sea surface temperatures and how the overall patterns might shape up. A lot of forecasters don't use this information. They really should. Now, this is the infrared satellite picture again from Monday afternoon, and you can see how impressive tropical depression number 7 is looking. Fiona's made a little bit of a comeback as well. You can see right in here. And of course, this right here, this is 90, this is the 90L system out here. So 99L. So, and that's also looking together pretty well as it's headed in this direction. But look at TD7. You can see the bands already coming in here. Very impressive. So, the infrared picture shows a lot here. Now, this is our dust from off Africa, and it's a pretty impressive dust cloud, but it's not that far south. And you notice, for the most part, it is not getting entrained into Tropical Depression 7 or the system 99L here out in the Middle Atlantic, and Fiona is clear of it as well. So as long as the dust stays up here like this, we should be in pretty good shape and does not get into the system. It's going to crank. Notice we have another decent wave coming off of here, some other clusters. We'll talk about those later. All right. And then this is the water vapor, and you can see a lot of really good water vapor here. No dust, no dry air, all the way into the Caribbean. This is a change from what we've seen the last several hurricane seasons, so that's kind of significant. And if we look at our shear, there's Fiona. This is from early Monday morning, late Sunday night, and you can see that very light shear here, only 10, 20 knots here, and this is the other system, the tropical wave here, also looking pretty good. And the flow is all west to east in this direction here. And of course, Fiona is going to try and make this gap between these two systems here, the two areas of high pressure. But I'm not sure if it's going to do that. So, and as we saw in the models, there's some indication that it's not going to go out to sea. Now let's talk about 99L. This is the tropical wave, and here it is as of Monday afternoon. You can see the combination visible infrared satellite picture, very nice there, east of the islands. And most of the models take it through the north side of the Greater Antilles or in the Bahamas. And if it's going to track this close to land, it's not going to be very quick in developing. The land masses are going to interfere with the system development. But once it gets towards Florida, the Bahamas, it might develop a little more. If we're looking at tropical depression number 7 or Gaston, well, it looks very impressive here. This is the morning satellite picture, actually late last night, looking very impressive indeed. And then this is the afternoon satellite picture from the folks out in Monterey Naval Research and Laboratory. Very nice looking system. Wow. And this is the satellite picture. I mean, that's a tropical storm already, folks. That's really what that is. And the look at the sea surface temperatures. I mean, that's 28, 29 Celsius already. It's in a perfect zone for it to develop rapidly. Most of the models here, however, this is this morning's tropical hurricane models, develop it rapidly and curve it way to the east of 60 longitude out into the open Atlantic Ocean. And most of the GFS ensembles show the same sort of thing. And there's the 18Z models show, again, the same sort of thing. They all take it, as you can see here. They all do this. They go and then out to sea like that. And that's very possible, but I'm not positive that's going to happen. And let me explain to you why, because this is where the synoptic meteorology comes into play, and you have to know what you're doing on the synoptic meteorology. Now, this is how the European model has us at 72 hours. We can see our three different features. There's Gaston, there's Tropical Depression Fiona, and there's 90L doing its business, a 99L. I incorrectly named that one, in the right along the north side of Haiti. But and then now this is at 120 hours. Looks like Gaston has turned to the north. There's a big strong cold front coming off the east coast here for Saturday, and there's the 99L system in the Bahamas. So far, so good. Now this is the upper air map at 96 hours. Now this is all based on the idea of Fiona dying out or moving into the gap. And you can see very clearly here that we have two very distinct features. We have a big dome here, a ridge here, and another one over the southeast, and there's a gap in this area. So Fiona's going to do this, and Gaston's going to do that, but I'm not certain if it's going to do that. If Fiona stays weak and does not develop, it may end up getting pushed back towards Georgia or South Carolina or even North Florida underneath the dome. So that's something we have to keep in mind. And if we look at the European ensemble, this is valid 96 hours out. Again, we can see that gap very clearly between the big dome over the southeastern states and the one in the central Atlantic Ocean. And it looks like Gaston is going to head for that gap and turn out to sea. But I'm wondering if it's really going to do that. Now, this is the European 144 hours. Okay, we can see 99L near Florida. And here's the trough right here. I'm going to highlight it so you can see what I'm talking about. This is the feature which is going to capture Gaston. But if for any reason this bypasses it and Gaston misses it, Gaston could end up turning back to the west. So I am concerned about that as a outside possibility. I don't think that's going to happen, but it might. We can see that enormous block in the pattern over North Canada and the deep trough over southwestern Canada. But this is a pretty warm looking map for the eastern third of the country going into the first week of September. 144 hours is the European ensemble, same sort of thing. There's Gaston. Is that trough moving east of Canada? Is that going to catch it, or is it going to bypass it? I just don't know. It looks like it'll catch it, but I'm not exactly certain. You know, if Gaston were to slow down or not be as far north by even a couple degrees latitude, it could make all the difference in the world. Now, here's the European ensemble 132 hours out. Now, the ridge looks really extensive here, and it looks like Gaston is trapped and it's not going anywhere. This is what I'm talking about. This is not a map which looks like it's going out to sea. But then, boom, at 168 hours out, the ridge splits in half. We have one big ridge in the central and eastern Atlantic, another one over Virginia, North Carolina, so Gaston's out to sea. I'm not positive that's going to happen. It might, it looks like it's going to, but I'm still a little concerned how it develops, that gap develops that rapidly between 132 hours out and then 168 hours. And the operational European follows that. 168 hours out, there's Gaston is gone. Now 99L is developing near Florida, as you can see. And then by 192 hours out, Gaston is paralleling eastern Bermuda. The other system is near Florida. And if you look at the ensembles, now this is the European ensemble from this morning. And you can see most of them take it out to 60 to 65 longitude and then turn it sharply to the northeast because of the gap. So that's a pretty good ensemble agreement. And then this is the 12Z run. And again, now what I'm doing here to see comparison of the trend, let's look at both these maps together. Now I've highlighted the 60-degree longitude line so you can see this. Okay, there's the 60-degree longitude line right here. See that? Notice how the 12Z runs are more east of that black line there, the 60-degree longitude line. So the trend appears to be shifting a little further to the east, if anything. And then finally, at there's day 10, we have that 99L is developed into some sort of hurricane in the northeast Gulf of Mexico. Gaston is gone, and the European has another significant tropical cyclone by the Cape Verdes at day 10. And then finally, well, there's more activity in Southwest Africa as the Cape Verde season is really cranking. Anyway, that's the report. Hopefully you liked the video. Any questions, be sure to hit me on the Facebook page or on the website. This is Meteorologist DT. I'll talk to you soon.